Hello, I'm Urban Martin, director of the Ground Truth Track at BSides Las Vegas. The next talk is from Diana Kramer and Norberto García Marín. It's called BigQuery as Security Detection Platform. Diana Kramer leads the security operations team for King. She's an engineer at heart who is passionate about video games, and she views security challenges as a state-based system that can be improved. Norberto García Marín is a junior security engineer at King, working with incident response, detection, and automation processes. If you have questions, the live Q&A will immediately follow the talk, and you can submit your questions via Discord in the Ground Truth channel. All right, so I hope you enjoy this talk.
Hello, and thank you for coming to our talk. We will present our lessons learned building a security detection framework in BigQuery, Google Cloud Platform's big data managed service. But first, let us present ourselves. Hi again, I am Diana. I'm a security engineer currently working at King, part of Activision Blizzard, and I'm leading the security operations team here. King is the creator of Candy Crush, if you haven't known, and as somebody just mentioned, we will take a lot of advantage of the sweet IP that we have in all those presentations. For the past 3 years, I have been part of our cloud leadership team. I helped understand and implement security controls, and also I've led the initiatives for detection and response over our cloud infrastructure and data. By origin, at heart and by trade, I'm a network engineer, so the cloud kinda has been a challenge for me. I was used with cables, hardware, physical infrastructures, things that you can actually touch. So this made it difficult for me to change the way I was viewing infrastructure, basically adapting to the software as everything philosophy. On the positive side, because there is always a positive side, the cloud gave a new, sometimes magical, world of opportunities through tools, integrations, and freedom that in the end kind of enriched me and the way I do approach security. So in the end, I loved exploring cloud tools and services, and especially GCP. And what I've been doing during the last 3 years is to come up with ways of leveraging them for security. And of course, I will always be a little biased, and my projects mostly focus on detection and response. Here you can find me on Twitter with Roruța, and the bat is a quick reference to my origin, as I am a Romanian. Norberto?
Hello everybody, I'm Norberto. I'm currently a junior security engineer working at King, in which I've been here for a year now. I come from a computer science background, so I have experience in different fields, including security, software development, and artificial intelligence. Actually, in my previous job, I researched and implemented cybersecurity solutions that leverage machine learning. I really enjoy this new cloud computing paradigm and the possibilities it offers. And at the moment, I'm holding a few Google Cloud certifications. I think we can use cloud-native tools to build amazing things, and so I hope you enjoy this presentation. Unfortunately, I don't have Twitter, but you can connect with me on LinkedIn.
Perfect. So now let's see the content of what we're going to be talking today. So today we'll start by stating the problem that we have explored, and that is using high volume data for security monitoring. Then we will introduce Google Cloud Platform's BigQuery, and of course its main functionalities and what basically made this project possible. Norberto then will introduce us to the design and implementation of the detection platform, and he will also present the next steps and where we actually want to take this project in the future, and that is BigQuery's machine learning capabilities. Now, let me state from the beginning that our story is not only about a cloud platform. It's not about tools. It is about how engineering is creativity and innovation. How we can embrace every new idea and let us be inspired, even if the final product ends up in production or just in the drawers of anecdotes. So without further ado, let us dig into the problem and this amazing little drawing here that represents a problem also in one of our games. So in this session, we will try to see how we can use BigQuery together with other GCP managed services to solve a problem that has been already solved and redesigned several times, and that is high volume data logging, storage, and querying. And if it's been already solved, why are we here, you might ask? Well, the existing solutions have shown themselves to be expensive, high resource consuming, difficult to maintain, and more or less to have issues when we need them most, and that is when we are exploring the store's data and when we are accessing it. How many times were we relaxed for having logs and telemetry only to discover when we needed them that the platform failed or the queries took too long? I personally have anecdotes from working in a SOC where analysts queued at the end of the month to perform reports, as there are platforms that basically don't support more than a couple of concurrent queries. Also, maintaining those platforms is extremely difficult. You need constant engineering support, and it can be a very monotonous task and challenging for the operational teams. So what we used for the requirements of our platform, it was an elastic guide on high-volume data sources. We are searching for a solution that scales fast, offers speed when exploring data, focus on what we are searching with rich filtering options, and the possibilities for visualizing data. High scalability is important because we can have bursts of data or new log sources being added, and we need a platform to be robust. Everybody has a story with an ML project forgot over the weekend or new log sources during an incident that need to be added ASAP. So, going for a cloud-managed solution, we don't worry anymore about scaling, the infrastructure for hardware, engineering time, or any expansion of the platform when this happens. Also, we need speed when exploring data. And this includes queries over a long period of times, as we know that dwell time of attacks can be very long. The recent report gives us insight that this time can be up to 2 years. Of course, it has improved lately, but still this is happening. BigQuery can query terabytes of data without worrying about memories, in minutes of a time, and with reliability. And as new malware families and techniques appear every year, Mandiant 2020 threat report estimates that more than 40% of them were previously unknown. We need to use several data sources and have strong baselines for detecting this unknown. The SQL language, together with many aggregation and parsing functions, offer us these flexibilities and allow for querying many tables and data sources. Visualization is also a very important part of detection and security investigations. Having native flexible tools makes the platform more powerful, and BigQuery has several integrations from its native data studio to Grafana and Looker. Looker in particular already presented several dashboards directly focused on GCP's data access and admin activity logs and have been presented in the last couple of days. Okay, so BigQuery, we talked so much, so how did we arrive to BigQuery exactly? So BigQuery is a GCP managed service that provides a highly scalable data warehouse. Basically, it's their managed big data platform. It allows to query streaming data in real time and have access to historical data. It uses SQL language for query, which actually saves us from learning a new syntax, allows for ingestion of any type of data, and with some help from a data engineering, can do actually some magic with it, being able to store the data in ways that facilitate analysis. Also, and Norberto will show this as well, its machine learning feature allows to build and operationalize ML models directly inside BigQuery. So, we arrived to BigQuery as our games produced huge amount of events. So basically, it's a big numbers game. King has more than 250 million monthly players. More than 50 million lollipops, that lollipop there, the pink one, more than 50 million lollipop hammers are being used every day in Candy Crush. We used to store all this data in a 50 petabyte, 500 nodes on-premise Hadoop cluster, and we were reaching its limits. So what our data team did was a benchmark for BigQuery and decided to migrate oral data lake to BigQuery, and that was with amazing results. And you can see all that benchmark, the migration, and so many interesting things that they did in our tech blog, and with a little example here. We have including a machine learning example that is actually simulating true players playing Candy Crush, so virtual players. And it's amazing to see how they model that. It's very fun. And there's also a talk from our teammate that did this in one of the next. So, what we did here was to build on this experience from King and use BigQuery also for our security data. And we actually started in a very obvious place, GCP's own cloud audit logs. GCP has several types of audit logs, including admin activity, And basically, you can see there all activity performed over GCP resources, like the creation of a VM or the change of permissions to a bucket. Then it has data access logs, which are kind of crude access logs. They can be very noisy, and they log access to any resource. So if you think about it, in a case of a bucket, in admin activity logs, you see its creation or IAM permission change. And in the case of data access logs, you can see read-write access and actions over that bucket. So this platform, in the end, proved to solve all our issues. And those are the main 3 V's of big data. Volume, can store huge amount of data. Velocity, it can query the data in seconds or minutes. And then variety, many different data types, and can query with SQL and with many other options for data analysis. And then, as we said, it goes even a step further, giving us the possibilities to explore its machine learning features. So, as it solved all our requirements for a storing and investigation platform, we have arrived to the need of creating detections. And not only atomic detections, but also multi-event or anomaly detections, which BigQuery opens a big real-time door to. This means that we explored how to apply to our data and to create a framework that leverages several cloud products, actually a lot of cloud products, to create a consistent experience. Native cloud first, very important. Norberto will show us now how he implemented this idea, taking advantage of BigQuery's characteristics and GCP's rich tool environment. Norberto?
Thank you, Diana. So, having the logs in BigQuery and the ability to leverage SQL queries to perform security detection, is there a way to manage, orchestrate, and schedule our detections? And the answer is yes. We would like to use cloud-native tools in the GCP ecosystem to build a solution. GCP offers different tools that can be leveraged with minimal operational cost, because most of them are managed or serverless solutions. Tools such as storage buckets, monitoring, PubSub, serverless cloud functions, and cloud schedulers can be integrated to build a solution. I'm very pleased to present to you our BigQuery detection framework, our serverless cloud-native solution with minimal operational cost. Next slide, please. We were designing the framework, we thought about our needs and our possibilities in the cloud. So, in the end, what are we trying to achieve? We would like to leverage BigQuery as a log analytics platform. BigQuery is the main pillar of the framework. This fully managed petabyte-scale analytics warehouse lets us run analytics over vast amounts of data in real time with non-operational cost. Logs can be stored in BigQuery and later be retrieved using SQL language, allowing us to use powerful analytics queries to perform any kind of security detection. Having those detection in place, we will need a mechanism to schedule and orchestrate the detection depending on some metadata that we define. And lastly, since we are working in the cloud, specifically in GCP, the best approach to build this solution would be using GCP cloud native tools that provide a managed solution and easily integrate with every service. With these requirements set, we will need to define detections tailored for BigQuery, using some templatized format that is easy to maintain and deploy. Also, use cloud-native tools for the logic such as cloud functions and cloud schedulers that we are going to talk about later. But these tools allow us to implement functionalities in serverless way that will have a minimal operational cost. We will need to build kind of a CI/CD pipeline in which we can perform some basic testing of the detection and automatically deploy them to be up and running. We only want to fill out a template and let the magic happen. Optionally, we may send the final results of the detections to ACM to perform further analytics or notifications. And lastly, there should be an automatic monitoring of our solution to make sure that every component is working as expected. And in case there's something wrong, we can be notified in time. Next slide, please. As I mentioned before, we will need a templatized way to create detection, so we can automate their deployment. For this purpose, we have defined two different jump templates. One for the detections and another one for the schedulers that will run the detections queries. The detection template has several metadata. It has a unique identifier to properly distinguish its detection. We also make use of the metermatics, in which we classify by technique and tactic. Also a category such as production or development, the severity of the detection, and your URL that contains the description and information about it. And lastly, the BigQuery query that will be executed when running the detection. Why do we need this metadata? Because we would like to schedule detections depending on these fields. Imagine that I'd like to run only specific detections that have a meter tactic, or even a specific category. We can leverage this metadata to discriminate detections and their schedule. For instance, as you can see, this detection in the screen was built to identify a simple SQL injection, in which the URI contains the word select, and different fields are returned. These detections, as I will explain in the next slide, will be stored in a BigQuery dataset, and therefore the schedulers will perform discrimination queries to get the detections to run. The scheduler template is more simple. It has a name, a description, a cron job that indicates the frequency in which the detections will run, and lastly a discrimination query that will retrieve the detections IDs that meet a condition. For instance, a specific meter tactic, category, or severity. As you can see, in this example, we would like to run detections that belong to the production category every 15 minutes. Next slide. What about the logic? Which tools are we going to use to implement this framework? We are going to focus on cloud-native tools that GCP is offering. We prioritize managed services that allow us to focus just on the development of the detections, and everything else is automated. We are going to use cloud storage buckets to store the detection definitions. This bucket is the entry point of the framework, in which security detections are pushed as objects. The bucket will cast the definitions to be ingested by another cloud tool. We are going to leverage BigQuery, creating a data set and a table for storing the detections definitions. These definitions are retrieved from the bucket that we previously have created. Using BigQuery to store the detections allow us to perform discrimination queries as mentioned before. To link BigQuery and cloud storage buckets, we are going to use a serverless solution called Cloud Functions. Cloud Functions are a functions as a service solution to run code in a fully managed way with zero shared management. These functions can be triggered by several events. In our case, these functions are going to update the BigQuery dataset accordingly, including new detections or even deleting some of them. We have leveraged Python 3 for the implementation that uses the BigQuery API to perform updates queries. These queries use the data manipulation language to run transactions. We are going to have another cloud function in charge of performing the detection query itself against the BigQuery dataset that has the actual data logs. This function receives a detection ID as input and will retrieve the detection query from our BigQuery detection dataset, and finally run the detection query itself. The result will be published to a cloud PubSub topic in which the results are gathered. This topic may be used by a CM to collect the results and perform analytic research or notification. Another cloud function will be in charge of orchestration when the detection runs. It will run a discrimination query to get the IDs of the detections that are going to be run, and then call the cloud function that performs the actual detection. This orchestrating function is called by the cloud schedulers. Cloud schedulers define when a group of detections, based on the metadata, are going to be run. The definition is done by the scheduler template that I have presented before, and they trigger the orchestration cloud function. Finally, we are going to use the GCP cloud monitoring solution to report errors. Whenever an error occurs behind the cloud functions that implement the logic, an alert will be raised and we will not be notified. Next slide, please. In order to deploy everything in an automated way, we are going to use a GitHub repository to store the logic, detections, and schedulers definition. We are going to leverage infrastructure as code, specifically Terraform, to deploy everything. Terraform is going to watch changes to detections and schedulers that are defined in GitHub, and so be able to deploy changes automatically. Terraform leverages Google provided to make changes to the GCP infrastructure. It also reads the YAML templates for security detections and schedulers, and performs a basic validation. In this way, we can add and delete detection or schedulers, and Terraform will handle everything. It will either parse a detection definition to the cloud storage bucket as the entry point, or create a new cloud scheduler that orchestrates groups of detections. To enable an automatic run of Terraform, we are going to use Atlantis. Atlantis is a software that integrates with GitHub to run Terraform when there is a pull request. In this way, whenever we introduce a change in the GitHub repository via a pull request, Atlantis will run Terraform and test and deploy the changes automatically. Next slide, please. Here you have an overview of the different components needed for adding detections. Let's imagine that a user wants to add a new detection to the framework. The user will create a new branch in the GitHub repository, commit the changes, and then generate a pull request. When the pull request is approved, Atlantis will trigger the Terraform workflow and deploy the changes if everything is validated. The detection will be uploaded to a GCP bucket, and this bucket will trigger the update cloud function, also known as storage watchers. This cloud function will update the BigQuery dataset that contains the security detections, and later it will be used when a detection is scheduled. Next slide, please. On the other hand, if the user performs a pull request with a cloud scheduler definition, Terraform will deploy a new cloud scheduler with that definition. This cloud scheduler, using a cron frequency, will just trigger the orchestration cloud function that will run a discrimination query to get the group of detections ID to run. Then, this orchestration function will trigger the detection function, one instance per ID. A good thing to know about cloud functions is that they can massively scale, and we will have independent instances per detection. This detection function will retrieve the detection query from the BigQuery detection dataset and perform the detection query against a BigQuery dataset that contains the data logs. Finally, the result is published to a Cloud PubSub topic, which an external CM can make use of it for analytics or even notifications. Next slide, please. Finally, here you have a complete overview of the components that integrate the architecture in a single image. The user can either push detections or schedulers, and Terraform will trigger the corresponding path to update the framework. Also, the monitoring is running behind the scenes, ensuring that everything is properly working and notifying us otherwise. Next slide, please. When a detection is run and has a result, the result is sent to a PubSub topic using a JSON format. It generates a single message per detection result. Here you can see messages published to the GCP PubSub topic. In this example, the detection with ID 1 has 5 results. These results can be ingested in real time by centralized log tool or CM to perform further analysis or notifications. Next slide. A result contains some metadata about the detection, such as ID, measure technique, and measure tactic. And lastly, the result itself and a timestamp. The result is just the data retrieved from the BigQuery query, and its fields vary depending on the security detection that is being run. For instance, this detection has a date, a source IP, an HTTP method, the URL in which we found the SQL injection, notice the select word at the end of the string, also an HTTP response, the packet size, and finally the user agent. Next slide, please. Imagine that a detection is malformed. or some error occurred while retrieving data from BigQuery. How would you be aware of this? We leverage cloud monitoring to create policy alerts when an error occurs during a cloud function execution. An incident is created when a cloud function prints a message with error severity. Then a notification is sent by email or even to a CM. Thus, we can timely investigate the error. Next slide. Here you can see an example of an error triggering due to a table that does not exist. When the cloud function is executed and runs the query, if some error happens, it will trigger an alert tracing all the error information. Through this alert, we can check the error alert inside in GCP and see all the errors that are being triggered in real time. Here, we can get more context about what actually happened and the Python exception of trace in our example. Using this trace, we can properly identify the problem and apply appropriate fixes. Next slide, please. Finally, let's talk about our future plans on this topic. It's good to define detections and automatically deploy them, but wouldn't it be awesome to have detections in place without even defining them? GCP offers different tools that we can leverage to cope with this situation. We can create an artificial intelligence-based anomaly detection model directly built from the data logs. This model will be capable of detecting outliers in the logs, firing an alert when something is not expected or classified as a possible threat. For this purpose, we can use GCP Dataflow to perform stream data processing. Dataflow is a serverless batch and streaming data model for parallel processing pipelines. It relies on Apache Beam open source project to implement the processing workflows. Using Dataflow, we can perform initial data normalization and feature extraction from streaming logs ingested from BigQuery, where the data logs are stored. Then we can perform outlier detection, leveraging a machine learning model that we have trained beforehand. The model can be built using BigQuery itself. BigQuery provides a machine learning model in which you can create models using standard SQL queries. In our case, we can train a k-means clustering model to perform unsupervised learning and identify anomalies, or even use an autoencoder to build a deep learning anomaly detection model. Besides the BigQuery machine learning model, there are specific GCP machine learning products to build a model. We can leverage Vertex AI to train a model based on the TensorFlow library. Therefore, it's highly customizable and tunable. To sum up, independently of what product we choose to build the anomaly detection model, we are going to achieve a real-time outlier detector that works in streaming, allowing us to timely detect threats. The result of this real-time pipeline can be exported to a visualization dashboard and enables organizations to create alerts and action for automatic mitigation. And this is our future plan for our framework that we expect to implement it very soon. Diana is now going to present our conclusions.
Wow, Norberto, it was amazing to see how many tools Cloud gave us and how many you have used for this project. It's basically like a Lego, pieces that allow our imagination to run wild. So Norberto used here around 10 different cloud services. And yes, I will use that word again. It's almost magical. It helps us get from a basically hackathon idea to a full working framework solution just with imagination, engineering, and a little sweat here and there. This is a great example how creative security engineering actually is. We start with an idea or a need and go looking around how to combine all we have available to create systems that not only solve problems, but do so fast, efficient, and of course, fun. And this is the important takeaway. Engineering is fun, and it's great to discover and play with new tech. And cloud brought new challenges to security, of course, but also new toys and opportunities. Even if sometimes it's difficult to adapt to the new philosophy, The result of applying the same engineering principle to the new world helps security and its engineers basically keep up with the same pace with what tech evolves. And one of the main engineering principles is that every design and system can be always improved, and there is a next step always for our project. We really, really hope that our detection framework is an inspiration for the possibilities we have and gets you as excited as we are about security detection and cloud computing. So thank you very much for letting us share it with you, and please, if you have any questions.
Hello, campers. Hopefully you're all having fun and none of you have gotten lost here in the random forest. We have Deanna and Norberto here to answer some of your questions. So if you haven't already, please put them into the Discord in the Ground Truth channel. So I think we have, let's see, one here right now. From a username I'm not sure how to pronounce. What was the most difficult part to orchestrate to use GCP BigQuery as a detection source?
Okay, hello. I think that can be answered from 2 points of view. So I'm going to give maybe the first answer, how the idea and how to actually think about it and what was difficult to start approaching it. And then maybe Norberto from the actual implementation part. So for us initially was because it was a new environment. Like we had the data there, but we never thought, we were just using about it as investigation and threat hunting, but we didn't think for a long time to use it as a detection source. Maybe as we just talked, as we're used to with security platforms, with dedicated security platforms for that. So this was a new environment and it was a little weird to use a general data platform for this. And it took us a while, but we actually got inspiration for projects like Anadot, which also there are some presentation that King made around using that data for seeing deviations from baseline. And the fact that more and more projects appeared around orchestration, around big data in the last 2-3 years. So we were just like, why don't we start doing it as well? Why we have the data there, let's do something. And I think it also helped having more knowledge about how to use those, about what orchestration means, about what detection as a code mean, about other GCP products. And then the more you knew, those Lego parts, you start putting, the more Lego parts we had, we start putting them together. But I think the difficult part was the learning curve, getting the Lego pieces together.
Yeah, I actually really liked what you said in the presentation about engineering being kind of a creative process or a creative outlet. And I guess, in that sort of vein, do you have any advice for people who might be more used to working with security-focused tools, kind of transitioning to a more general data tool?
Again, I'll talk from my point of view, and then if Norberto has to ask. So this is a story that will start when I was 7 years old, and my mother was not allowing me to make my drawers for the drawing class because they were too ugly, and she was doing them for me. So I was raised in an environment where everybody was telling me I'm not creative. I just know math and physics. And I had that idea that I'm not creative for all my life, and that engineering is a very, that the engineering ideas are not creative ideas, are structured ideas. And this changed actually with a team of tech writers, which are the most creative people I know, doing the security awareness program. And they taught me that actually those things that we're doing, they are creative. Putting those puzzles together, getting ideas of how to transmit an information, on how to build a product, on how to create a function, where that's creativity. And I think what's most important here to change the chip is to understand this and start exploring. And yes, we're used with security tools, we're used with some syntaxes, we're used in a framework, in a structure, in a stack. Just go there, find the first platform, the first tool your team uses a lot. You have a tool in your company, I don't know, whatever it does. Go and see how people use it. And go and see how you can leverage that for security, understand why they're using it. And any data source is interesting, and no matter where it is. Now we know from Norberto that even if it's something on-prem or something in AWS or in GCP, you can create somewhere a function to query it with the data that is important. So I think the secret is a little bit open the mind and see pieces, get Lego pieces from wherever.
Yes, actually, from my point of view, I think that GCP and cloud computing in general is fun. And that's the important thing, that if you want to build something and have fun, that's the right path. So I think maybe leverage tools that you can build from scratch and code that tools are awesome to have everything in place.
Cool, thanks. There's another question here from Jeff. So what would you not use this pipeline for? For example, what would you say this is bad at doing?
Well, this pipeline was built for security detection. So I think for security detection, it works well. But I don't see any other things that it would be bad at this. I mean, this project is for security detections. I don't really, we haven't thought about other use cases for this. So as far as they are security detections, it will work well.
Yeah, that makes sense. Would you say that's like one of the benefits of using a general platform? Is that you can kind of do whatever with it, or?
Yeah, of course. You can build whatever you want. That's a good point. Imagine you want to integrate another thing and build, I don't know, other pipeline. You can create several pipelines for different things. So it's up to you. I mean, you can build everything you want.
And it's pretty general, actually. This is security detection, but imagine you have a web app and you need to make some traffic lights for seeing if the app fails, and you have logging for that application, and you know some error codes that are happening. So it can be used with anything that queries logs, basically, that queries data sources, and that you have a structured way of adding them. So it doesn't matter what the data is or what the result is. And it can, as we said, it can do it atomic, it can do it over several events. It can even do it over baselines and searching for anomalies. So you have anomalies in normal web application. You know, you can see when you have peak of traffic. You can see when you have fells of traffic or of anything, and that makes you see that there are questions around there. So the idea, and this is one of the cool things about a general platform, go to the experts. So go to a BigQuery expert. And this is how we did. When we try to understand how this platform works and what type of SQL queries we can do and what kind of detection, we went to somebody in our team that is expert in BigQuery, and they worked with it for 3-4 years. And they stood in the hackathon with us, and we were explaining what we tried to do. And they started shifting our data around and said, no, how you're storing it is bad. You need to do it like this. And this also goes with the general platform. You have more people that know it. If you go to just security, you'll always have this little pool of us that did the trainings and everything. If you go to a general one, you have so many more people that can help you and you can ask. And I'm a horrible human. I'm always going and bothering people with questions and taking advantage of them. So I think this is also very positive and it helps our industry a lot to be this open, you know?
Yeah, actually tagging on to one thing you mentioned there, with the detection rules that you're using, have you had to create most of them yourself or with other sort of collaborators that you're working with? Have you been able to leverage vendors or, repositories of detection rules or anything like that?
So the ones that we're having right now, as we said, we started this POC over GCP's own audit logs. So some of them were created by us because in the last 3 years, We were trying to understand behaviors around it, and doing a normal detection engineering life cycle of a detection from several points of view, database, the tag base, and all that. So some of us, we created. Others already are public. Like Splunk Enterprise Security has a lot of detections already prepared for cloud behavioral for their platform, but they can be adapted. So there are already a lot that can happen. Basically, you can even go to a Sigma repository and get everything and just convert it to SQL. So, which can also be done with a function. But the idea is that those things can be happen, and we used everything around it. And as you have other logs, you can even have a threat intel feed and just do IOC direct matching. So there are a lot of options. And Google actually, 2 weeks ago, they had their security summit. One moment to find my mouse. And they even proposed to take something similar and even to take it to a next level and create this as a stack. So you might at some point even integrate with other products. And imagine we have 5 detections, just 5 detections done by Norberto that are querying BigQuery, and the next 5 in the functions, instead of querying BigQuery, they query your Corelight products, or they query your Suricata or Zeek repository of detections and get the detection feeds from ET Pro or whatever you're ingesting them, and you have those data, and then you just need to change the filter inside the query. So that is completely possible. And I'm going to share that link that Google was talking about and how they were going in the same direction. So basically, it's this idea of using any product, and with those little functions, you can interconnect anything.
Interesting. So do you have some plans for additional things that you'd like to integrate in the future going forward? I don't know if you're using sort of, threat intel feeds from different sources or things like that.
Norberto, maybe talk a little about the machine learning plans.
Well, yes. Well, first of all, I think we can integrate some Intel thread from the internet to a BigQuery table, so we can have those IOCs or thread information in that table and query that table and perform the detections and join all the tables that we have. And so using that, we have like more information about everything, and we can build consistent queries. And also talking about machine learning, our next steps for this project is creating a machine learning model to detect an anomaly detection model to detect outliers. So we expect to work on this in the next months, and we will create a blog with this information and make it publicly available. So it will be awesome, I think.
Yeah, it sounds cool. Exciting. What about data visualization? Are you doing anything interesting with that?
Well, actually, we mentioned that there are several ways where you can extract this data for visualization, and that was one of the other reasons that we chose BigQuery, or we saw BigQuery helping, the famous dashboards and everything. And exactly, also in the past 2-3 weeks, Looker is a data visualization platform that works directly integrated with BigQuery, and actually is from Google now. So GCP brought it, I don't know how it is. And you can do yourself the dashboards there, and they can query huge amounts of data. But they actually put a project up where, and I think it was after we recorded that call, and okay, if I'm not mistaken, where they're already making pre-built dashboards over the GCP audit logs that we talked about. It's mapping them to Mitre, and I think it even had some abilities to extract more data. So that is something that you can test at any moment, and they directly go. You just connect it to BigQuery, to the logs that you have, and then those kind of platforms do offer you the possibility to start creating your own dashboards with this huge amount of data. So you can actually see baseline of terabytes of logs from one day to another without, without any loss and in real time. And this is pretty amazing. And we also we've seen this in other teams. Also in the blog is how they are monitoring our own infrastructure with that. And we were seeing the dashboards and we were like, wow, you can see that much data so smoothly and so in real time, and to get notification, we run that. How do you do that? Tell us, teach us. So we just went knocking on doors. And basically this is how we discovered it, because the experts in the end in those products is not us, and we will never be experts even in our security tools. I think they have their experts, and something new appears and you're just using a little fraction. So in the end, let us adapt what we already have and use our experts around it. And this it's amazing. It's super fun. Like Norberto said, we're super excited.
Yeah, that's very cool. It is a lot of fun. I love working in this space as well. So we're getting pretty close to time here. I don't see other questions. Okay, 4 minutes. Yeah, I don't see other questions coming through in the chat. So this was like a wonderful talk. Thank you both for being here, and thank you for getting up in the middle of the night to come do this Q&A session. I hope the weather is not too bad. And is there anything else that you want to talk about before we go to the next content?
I think we kind of covered everything. I just want to reiterate around this idea to just go and try them. This is one of the amazing things that engineering has. You can actually be a squirrel and go to the next shiny thing, and that little attention span that we have when we go to another shiny thing, it's actually positive. It doesn't matter that we all have 1 million labs started and not finished, and 1 million drawers full of those projects we just did one weekend. Those are the Lego pieces. That's what creativity means. We don't need to make every time a masterpiece, but at some point those Lego pieces will come together and they're going to make an amazing talk, or you're going to have so much fun creating it. So just keep being curious. That's what it's all about.
That's what it's all about. Awesome. Thank you both so much again, and I hope you have a good night. Thanks, everybody.
Thank you. Bye.